Hello dear students, welcome to Physics Master YouTube channel. In this video we will be solving some problematics on the concepts which we studied in the previous session videos. So as we know that in the previous classes or the previous videos we studied about the concept of heat, temperature, specific heat capacity and the principle of method of mixtures. So based on all those topics, here we will be solving in some basic questions on the same topics. Okay, so here the questions that I am referring are from the textbook that is the publishers Selena. Okay, so there I have referred the questions and and I will solve all the questions. So both the example questions and exercise questions are mixed here. Okay, so in this video we will be solving only the basic questions in order to understand the concepts very clearly, and then we will be solving the application level questions. So here all the questions which I solve in this video are for 2 marks. Okay, so only for 2 marks, and in the coming video, next video, I will be solving all the 3 or 4 marks questions which are important, and then we will be solving some questions which have been asked in the annual examination also. So I'll be referring that question paper, and I will mention the question paper on which annual examination in which year the question has been asked, and those questions also we will solve here. So let us start today's class. See, the question has been we will solve 2 questions, and the first question is like this: an iron ball requires 5000 joules heat energy to raise its temperature by 10 degrees Celsius. Calculate the heat capacity of the iron ball. This is the first question. And so the second question is, if its mass is, that means if iron ball's mass is 1.1 kg, find its specific heat capacity. So I have written in the shortcut SHC means what? Specific heat capacity. Okay, fine. So let us solve this one. See, what you need to observe when the question is being asked are, okay, so first look at the values, look at the numerical values and the units. So by looking at these numerical values and the units, you can say which quantity is that. Since here they have given in terms of joules, we have to take in terms of energy. Which type of energy? Heat energy. So the heat energy that they have given is what? 5000 joules. Okay, so that much amount of heat energy is being absorbed by iron ball, and the iron ball is raising its temperature by 10 degrees Celsius. It is not, the temperature of the iron ball is not 10 degrees Celsius, it is rising its temperature. So the temperature of the iron ball will initially be some value. Okay, say in room temperature, say 23 degrees Celsius. Now how much it is rising? It is rising to 10 degrees Celsius. That means 33 degree, it is attaining 33 degrees Celsius. So this 10 degree we should not take in terms of what? Temperature only. This value will become what? Delta T. That means what? The change in temperature. Okay, so the change in temperature is how much? 10 degrees Celsius. So say for example 23 degrees Celsius, the temperature of the iron ball initially is 23 degrees Celsius. Now it is rising to 10 degree, then it will become what? 33 degrees Celsius. Delta T will be equal to 33 minus 23, that will be equal to 10. But 23 degrees Celsius they have not given in the question. Since so I am just explaining to make you to understand the concept. Okay, fine, clear. No need to write all these things. If you mention just delta T is equal to 10 degrees Celsius, then that is more than enough. When we have to mention it as delta T, when they have given that the word to raise the temperature or change in temperature, if in the questions if they mention these type of words, then only we can take this as change in temperature. Okay, fine. Now calculate the heat capacity of the iron. Heat capacity means what? C dash. Okay, we know that the formula for C dash, what is the formula for C dash? That is Q divided by delta T. This is the formula for C dash. In the previous video I have explained all these things. So what is the value of Q? That is 5000. Delta T is how much? 10. So if we cancel, we will get C dash is equal to how much? 500. The unit is very important. See, here the heat energy is in terms of joules, hence I can write it as joules, and delta T in terms of what? Okay, so that is 10 degrees Celsius, which I can write it as what? 10 Kelvin also. Why? Because the change in temperature remains same. Okay, irrespective of the units, the change in temperature will remain same, hence I can take it as what? 10 Kelvin also. So I can write it as joules per Kelvin or joules per Celsius, no problem. Okay, so both the things I can write. This is the answer for what? First question. Now in second question, what has been given? Okay, so in question B, if its mass is 1.1 kg, if its mass, that is m is equal to 1.1 kg. Okay, so calculate the heat capacity of the iron ball. Heat capacity is means what? C, small c. So there is a relationship between C dash and C. Okay, so that we need to know. What is the relationship between C dash and C? Okay, so C is equal to, it is the amount of heat required to rise the temperature of unit mass to 1 degree Celsius. That means C dash divided by M. What is the value of C dash? That is 500. Okay, what is the value of M? That is 1.1. So if we solve, it will become 5000 divided by 11. So if you remove this point, always try to, so don't go on solving if decimals are there. Okay, so if decimals are there, try to convert it into fractions. So if point is there, if I am moving to right side, okay, I have to put 0 to the numerator. Now if we solve, just pause this one and solve and get the answer. Okay, fine. So if we solve, you will get what? 11 ones are 11 4s are 44. Okay, so what will remain? 6 will remain. 11 5s are 55. What will remain once again? Okay, so 5 will remain. 11 4s are 44. Once again 6 will remain, point. Okay, so then once again it will become 60. Okay, so 5. So it will goes on like that only. It is a non-terminating decimal number we will get. Hence, this is more than enough. 454.5. We are calculating what? Specific heat capacity. The unit of specific heat capacity. See here. Just look here. Here the unit of heat capacity is what? Joules per Kelvin. I have to write joules per Kelvin. And in the denominator, what is there? Mass is there. So joules per Kelvin kg. Okay, or you can write it as what? 454.5 joules per kg Kelvin. So both the things are correct. Okay, so this is the answer for the first question. Now let us move to the second question. What is there in the second question? See, if we observe, I hope you understood this question, first question, right? Yes. Now if you observe the second question, calculate the heat energy required to rise the temperature. Here also we have to find out the amount of energy to required to rise the temperature of 2 kg of water. So here they have given mass as 2 kg and we need to rise the temperature from 10 degrees Celsius to 50 degrees Celsius, and they have given specific heat capacity in terms of 4200 joules per kg Kelvin. They have given in terms of what? Kelvin, but the temperature they have given in terms of what? Degree Celsius. Now here you can understand very clearly. Okay, so how to convert it into Kelvin also. So I'll just make you to understand each and every concept very clearly. See here, mass they have given, that is 2 kg. Okay, here the change in temperature, that is delta T is equal to maximum value. What is the maximum value? 50. What is the minimum value? 10. Okay, so the change in temperature is nothing but what? 10. Okay, so 40 degrees Celsius. So this is in Celsius also it is same, in Kelvin also it will come what? 40 Kelvin only. How we will get 40 Kelvin? Now see, just okay, so 50 degrees Celsius in Kelvin scale, how to write? 50 plus 273, which is nothing but, okay fine, 323 Kelvin. 10 degrees Celsius, how to write? That is 10 plus 273, which is nothing but 283 Kelvin. So delta T is equal to maximum value 323 minus 283. So if I solve 330, okay, so 32 minus 28 means what? 50 Kelvin. Look here, irrespective of units, difference in units, the change in temperature are okay, so the value is same. Hence I can write it as what? 40 Kelvin only. Yes. Now if we go on solving, the specific heat capacity small c they have given 4200 joules per kg Kelvin. What we need to find out? We need to find out heat energy, which is nothing but Q. Q is, so we have one formula, Q is equal to M into C into delta T. From where we got this formula? That is factors affecting the heat energy observed to rise the temperature. In that concept we got this formula. What is the mass? 2 into, see just look here, see when it has been given in terms of kg, here also the mass has to be in terms of kg. If it has been given in terms of grams, the mass has to be in terms of grams only. Okay, fine. So 2 into C is what? 4200 into what is the value of delta T, that is 40. So if you multiply, okay, so you will get as 8 into 4, okay, so 80 into 4200. So 42 into 8, 8 2s are 16, 1 8 4s are 32 plus 1 33. So 336 120, 3 zeros 1 2 3. Okay, so how ultimately we will get was how much? So 3,36,000 joules, or 3.36 okay, into 10 to the power of 1 2 3 4 5, 10 to the power of 5 joules. So both the things, whichever you write, it is correct answer only. Fine, clear. So these are the simple two questions. So I have explained in detail. So in the coming questions we will just put the values and we will go on solving. I hope you understood. Please pause the video and once again you solve these questions. Be very confident with respect to these questions, and then we can solve the bigger questions. Okay, fine. So let's move to the question number. Yes, the third question is what? Okay, so the question is like this: a metal piece of mass 50 grams at 27 degrees Celsius required 2400 joules in order to raise its temperature to 327 degree Celsius. Calculate its specific heat capacity. We need to calculate specific heat capacity, and what are the concept, the values that they have given, we have to tabulate. First step in physics while solving the problematics is to analyze the question and to tabulate the values. Okay, so the first one, first thing what they have given the mass is equal to what? 50 grams. Let it be, you write, just let us write in terms of grams only. Why? Because nowhere it has been mentioned in terms of what? Kg. Specific heat capacity or any other thing, nowhere it has been mentioned in terms of kg. So if nothing is given in terms of kg, you can write it in terms of grams only, no need to worry. Next, so the temperature is from 27 degrees Celsius to 327 degrees Celsius. Therefore, delta T is equal to T2 minus T1. T2 is the maximum value, which is nothing but 327 minus 27, which is nothing but 300 degrees Celsius or 300 Kelvin. Both the thing you can write. Okay, next we need to calculate specific heat capacity. Specific heat capacity C is nothing but what? They have given the amount of energy, that is is equal to how much? 2400 joules. So now what we need to do is, if we know that formula Q is equal to MC delta T, but we need to calculate only C. So therefore I will just bring the other two here, here multiplication, and if we bring towards this side, it will become what? Division. Therefore C is equal to Q divided by M into delta T. What is the value of Q? Q is 2400 divided by mass is how much? 50 into delta T is how much? 300. Correct? Yes. So here we can cancel the zeros. 6 4s are, okay, so now okay, 6 4s are 24, 6 5s are, okay, so what we will get? We will get 4 divided by 25. Okay, so 4 divided by 25 joules. Okay, so we can write in terms of what? Okay, so if we divide this one, here I will divide 25 4, okay, 0.0. So 1s are 25. What will remain? 15 will remain. Okay, so point is there. 6 are 150, so therefore 0. So how much it will become? 0.16 joules. So this we have taken in terms of joules, and mass we have taken in terms of grams, joules per gram, and temperature we can write whichever we want, joules per gram Kelvin. We can write in this way, or else if you want to convert in terms of kg, usually the SI unit of specific heat capacity is what? Joules per kg Kelvin. If we want to convert this in terms of kg, means just multiply it by what? 1000. Okay, so 0.16 into 1000, which is nothing but 160 joules per kg Kelvin. Okay, fine. So like this also at last you can do, or else you can write 50 in terms of kg. How can we write? 50 divided by 1000 kg. Like this also we can do. Okay, so then it will become what? 50 by 1000. Here we will get 50 by 1000. So the 1000 will be multiplied here. The same thing I have multiplied in the last. So in both the way we can solve. Clear? So here if you want to convert this grams into kg, we have to multiply by 1000. This one you have to keep it in mind. Why? Because if we take in terms of kg also, we will get the same value. Okay, yes. So this is the answer, 160 joules per kg Kelvin. So I hope you understood this question. Now let us move to the next, fourth one. So fourth one is quite different than the previous questions. See here, they have given an electric heater of power. So they have given the quantity power. Okay, so let us write this one. Power is equal to how much? 1000 watts to raise the temperature of 5 kg of water. So what is the amount of liquid that we have? 5 kg. Mass is equal to 5 kg, okay, of a liquid. From which temperature to which temperature? Yes, from 25 degrees Celsius to 31 degrees Celsius. Therefore delta T is equal to 31 minus 25, which is nothing but 6 degrees Celsius or 6 Kelvin. Both the thing we can write. Correct? Yes. So now we have to calculate the value, that is a C dash, which is nothing but Q divided by delta T, but here we don't know the value of Q. In order to get the value of Q, they have given some different quantity, which is nothing but power. Power they have given, whenever power is mentioned, they have to mention the time also. Why? Because power is nothing but it is the rate of work done. Okay, it is the amount of the rate of work done is nothing but what? Power. Now this work is nothing but what? Energy. Why? Because SI unit of work is also joules and energy is also the joules. That is not one of the parameter that we need to consider to say work and energy are same, but both are nothing but one and the same. Clear? Yes. So therefore work is nothing but energy is equal to P into T. Okay, so it is in terms of what? Watt. If power is in terms of watt, then the energy should be in terms of joules and time should be in terms of seconds. But they have given in terms of what? Minutes. So we have to convert it into seconds. So time is equal to 2 minutes, which is nothing but 2 into 60. 1 minute means 60 seconds, 120 seconds. So therefore Q is equal to, what is the power? Power is 1000. Okay, 1000 into what is the time? That is 120. So which is nothing but 4 zeros, joules. So this is the amount of energy that has been given to the water to raise its temperature from 25 degrees Celsius to 31 degrees Celsius. How much mass of water? 5 kg of water. Clear? Okay. Now we got the value, that is 0.0000. Okay, how many? 4 zeros, right? Yes, 4 divided by what is the amount of this one? The temperature 6 ones are 6 twos are. So this can be written as 2 1 2 3 4. Okay, so 20,000 joules per. Okay, so here only we can write 20,000 joules. Why? Because heat in terms of joules we have taken and temperature in terms of what? Kelvin. 20,000 joules per Kelvin. Okay, fine. I hope you understood this heat capacity. Now let us move to the specific heat capacity. Okay, so specific heat capacity is nothing but what? Heat capacity divided by mass. So therefore we can write it as 20,000 divided by what is the mass? 5 kg. 20,000 divided by 5. 5 ones are 5 fours are. So therefore 4,000 joules per kg Kelvin. This is what the specific heat capacity. Okay, so specific heat capacity of the water. Okay, yes. So these are the concept and this is the question and these are the answers. So very simple. Okay, so here you can get easily 2 marks. No need to worry about the concepts. Concepts are very clear and the formulas, if you know and if you know how to apply, so all these things will add to your marks. Okay, fine. So now let us move to the next question. Okay, so let me rub this one. Yes, we have 5 questions here. These are all the numerical questions. Okay, so that means exercise questions we have here. So let us go one by one. Let us go from 5th. Okay, so let us solve the 5th question first. So the 5th question is, okay, so here from here to here. Okay, so the 5th question I have written 1300 joules of heat energy is supplied to raise temperature of 0.5 kg of lead from 20 degree Celsius to 40 degree Celsius, calculate the specific heat capacity. The answer part I will write here. Okay, so the complete answer part for each and every question I will write here. So here the first question is what? Fifth question answer, fifth question solution. So they have given, just pause and solve the question, very easy. Okay, so the basic 2 marks question, they have given the heat energy, that is 1300 joules, and is supplied to raise the temperature. Mass is equal to 0.5 excuse, so 0.5 kg, and the temperature, the change in temperature delta T is equal to 40 minus 20, which is nothing but 20 degree Celsius, 20 degree Celsius or 20 Kelvin. We need to find out specific heat capacity. Specific heat capacity is nothing but C is equal to Q divided by M into delta T. Okay, this is the simple formula. Okay, so that is nothing but 1300 divided by 0.5 kg, 0.5 into 20. Okay, so shift this point toward this to the right side, it will become 1300 divided by 5 into 20. Here once again 00 will gets cancelled, so once again 1300 divided by 5 2s are 10, so 00 gets cancelled, 130. Okay, so I'll write here only. So here 1300 divided by 10, so once again it will get cancelled, 130. We are finding out specific heat capacity, hence the unit will become, so yes, joules per kg Kelvin. Okay, so here I will write 130 joules per kg Kelvin. So this is the simple answer. Okay, fine. So now I think you came to know about the fifth question, so I'll just rub one by one once I complete the question. Okay, yes. So now let us move to the fourth question. Okay, so fourth question is also simple, so I'll write here fourth question answer. Okay, let us see what are all the things, what things are there in the fourth question. Calculate the amount of heat energy, that means we need to find out the value of Q we need to find out. Okay, so Q we need to find out. They have given required to rise the temperature of 100 grams. Okay, so the mass they have given, mass is equal to 100 grams. So 100 grams we can write it as what? 100 divided by 1000 kg. So initially only let us convert. Why? Because in order we have to write in terms of always the SI unit is preferable. Okay, hence let us convert this into kg here only. From 20 degree Celsius to 70 degree Celsius, which is nothing but delta T is equal to 70 minus 20, which is nothing but 50 degree Celsius, which is nothing but 50 Kelvin. If the specific heat capacity of copper is how much? So here copper they have given 390 joules per kg Kelvin. C is equal to 390 joules per kg Kelvin. So this is the tabulation part. Now just substitute all these things by writing formula mc delta T. So 2 marks, how they will give the weightage for this answer means, so the tabulation part it will be allotted for half a mark, formula you will be having half a mark, and then calculation and writing the conclusion and answer you will get 1 mark. So total 2 marks. Okay, fine. Now so mass is how much? Is 100 divided by 1000. No need to write in terms of decimals here. Why? Because once again calculation we have, hence directly write whatever the value that we converted here. So 100 divided by 1000, very simple calculation. Delta, okay, C value is what? 390 into what is the delta T value? 50. So hence here 2 zeros, 0 get cancelled, 0 and here also 0 get cancelled, 5 into 0 is 0, 5 nines are 45. Okay, so 5, 4 here, 5 3s are 15, 15 plus 4 19. Okay, so Q is equal to 1950 joules. This is the very simple and simple calculation, and 1950 joules is the answer. Clear? Yes, fine. Let me rub this one and let us go for the third question. Here if we observe the third question, a piece of iron of mass 2 kg has a heat capacity of 966 joules per Kelvin. Find the heat energy and specific heat capacity they have asked. So let us tabulate the things. The question number 3. Okay, so question number 3 answer. Okay, here they have given the mass is equal to how much? 2 kg, and the heat capacity, that is C dash, is equal to 966 joules per Kelvin, and they have given to raise its temperature to 15 degree, that means delta T should be equal to 15 degrees Celsius, or which is equal to 15 Kelvin. So that means it will be in terms of room temperature, we need to raise its temperature by 15 degrees Celsius. So hence we have to take in terms of what? Delta T. They have given okay, so these are the values that they have given, I think, and we will go with the calculations. Now let us calculate first. First, what shall we calculate? We will calculate the C. C is nothing but C dash by delta T, sorry, C dash divided by M per unit mass, right? Okay, fine. So specific heat capacity is equal to heat capacity divided by M. Therefore heat capacity is how much? 966 divided by M, that is 2. 2 ones are 2 4s are 2 8s are 2 3s. So hence 483 joules per kg Kelvin. So this is the SI unit of what? Specific heat capacity, and we have written the same. Clear? Yes. Now let us move to the next one, which is nothing but what? Heat energy. Q is equal to M into C into delta T. Okay. What is the mass? 2. What is the value of C? 483 into what is the value of delta T? 15. So now if we multiply 15 2s are 30. 30 into, okay, 483 into 483 into 30. So if you calculate, you will get 0 0 0. 3 3s are 9. 3 8s are 24, 2, 3 4s are 12 plus 2, 14. So it will become 14490 joules. So therefore, the heat energy that is given to the iron piece to raise its temperature to 15 degrees Celsius is how much? 14,490 joules. Okay, so this is also a simple question. I think you understood. Let us move to the next question. The next question is what? The next question is also simple. Question number 2, we have 2 sub questions there. Let me rub this one. And the 2 sub questions includes the information like calculate the heat capacity of copper vessel of mass 150 grams. They have given the mass. Okay, so this is second one answer. They have given the mass, and the mass is how much? 150 grams. 150 grams. Let us convert it into kg. 150 divided by 1000. 150 divided by 1000 kg. Okay, and the specific heat capacity they have given, C is equal to 410 joules per kg Kelvin. Okay, so we have to calculate heat capacity. Therefore heat capacity C dash is equal to that is okay, so we have the relation, that is specific heat capacity is equal to heat capacity divided by mass. Therefore heat capacity is equal to specific heat divided into mass. Okay, so if we multiply this one, cross multiply, we will get heat capacity. What is the heat capacity? Specific heat capacity 410 into what is the value of mass? That is 150 divided by 1000. It has to be in kg. It should not be in grams. Why? Because specific heat capacity is in terms of kg. Hence it has to be in terms of kg only. See here, 0 0 gets cancelled, 0 0 gets cancelled. Here 41 into 15, you have to multiply 41 into 15. So 5 4s are 20, 1 4s are 4. So next 5 1 6, 615 divided by 10. 5 4s are 20. Okay, so 1 1s are 1 4s are 4. Okay, so yes, correct. So if you remove, if we remove this 0, we have to put the point towards left hand side. It will become 61.5 joules per Kelvin. Sorry, joules per. Okay, this is specific heat capacity, right? Okay, so joules per Kelvin, that is the correct answer. 61.5 joules per Kelvin. Okay, so this is the correct answer. Now let us move to the second sub question, that is B. This one is A, and let us move to the B, second sub question. So if we are solving second sub question, how much heat energy will be required to increase its temperature of the mass of the vessel in part A? That means in this question, to increase its temperature from 25 degrees Celsius to 35 degrees Celsius. Okay, so the delta T value will be 35 minus 25, which is equal to 10 degrees Celsius, which is equal to 10 Kelvin. Correct? Yes, fine. So now the mass is same, specific heat capacity is same, heat capacity is same. We need to get the value of what? Q. Q is equal to, we know the formula, M into C into delta T. Okay, fine. So what is the value of mass? That is 150 divided by 1000 into what is the value of C? That is a small c, that is 410 into what is the value of delta T? Delta T is what? 10, correct? 25 degree. Yes, fine. So now 0, 0, 0, 0. 1, 2, 3. 3 zeros will get cancelled. Here also 3 zeros will get cancelled. 41 into 15. Already I think we calculated, that is 615. So 41 into 15 is nothing but what? 615 joules. So the heat capacity, or the heat energy that is required to rise its temperature from 25 degree to 35 degree is 615 joules. Clear? Yes, fine. So I hope you understood these concepts. Very, very easy. So try to understand these things. Why? Because the concepts or the problematics which we solve upon the principle of method of mixtures require all these basic concepts. Clear? Yes, fine. So now let us move to the last question, that is the first. Yes, let us move to the first question. The first question is very simple. So they have given that by imparting an heat to the body, its temperature rises to 15 degrees Celsius. That means they have given delta T is equal to how much? 15 degrees Celsius. It is rising. Initially the temperature will be having some value and it is rising to 15 degrees Celsius. If we minus the maximum temperature to minimum temperature, we will get what? 15 degrees Celsius, which is nothing but 15 Kelvin. Okay, so this is only the answer. Clear? Very, very simple question. I hope you have understood all the 5 questions which I solved now. So the initial questions I have explained in detail, but these questions, so I have done with a bit speed. So why? Because I hope you are very much familiar with those formulas and everything. So you also have to be very quick, okay, to solve these questions. Why? Because 4 marks questions and 3 marks and 4 marks question include these as a basic things. Clear? Yes, fine. So I hope you understood all the concepts. Let's solve the remaining questions which will come for 3 or 4 marks in the coming video. So I hope till then keep on solving these questions and extra questions also. Please refer to the previous year question papers. If you have any doubts or any queries, please put me a message in the comment box, or put me a query in the comment box. So please support, subscribe and share. Thank you.